So hello everyone, this is Shanti Carlos Casanillo, and today we're gonna discuss activity number 10. It is a synchronous motor. So as always, I already have the material like data acquisition, power supply, synchronous motor generator, and the prime mover or dynamometer. I already copied the figure I will flash here. The This figure is called Y connected synchronous motor, and I'll just turn on the main power supply and record the voltage on display data acquisition and on the phasor analyzer. So let's start. I will check the data and I will here. Wait. Let's just X this. It's already turned off. My bad. So gonna insert the phasor analyzer and then check all this one. And here we have our volts 1 and then volts 2 and I mean E1, E2 and E3. We have 124 here, and then I1 1.5, 1.5, then I3 is 1.5. We also have our phase here and also the frequency. So let's check the RPM. Our RPM is about a 1749 RPM. So I flash the data here. Okay, I flash the data here. Okay, next. As observed on the shafts on the motor dynamometer, in what direction does the rotor rotate? So let's see in what direction the rotor will rotate. Okay. Okay, it is a counterclockwise. So now we can proceed on the record procedure number 9, and I will flash the data here. And then we will try to answer that. Okay, let's go with the phasor diagram, guys. Let's do this. So here is our data. We have our E1, E2, E3, and E1, I1, I2, I3. We have our phase. Okay, and we have our frequency. Okay, now let's move on to 10%. So let's do 10. Wait. So 10%. Okay. So let's check our record. So for 10%, nothing changed. It's only a point. We have our E1, E2, E3. Of course, their phase, and I1, I2, I3. Okay, now let's change the the still RPM is the same. Next is our 20%. Okay, 20%. Okay, let's change. Then let's check our okay, so we have our E1 again, E2, E3, I1, I2, I3 in their phase. And I will flash the complete data here above my face. Okay, let's jump into the 30%. Okay, 30%. Let's do this. And then yan, our E1 still the same. Our voltage E1, E2, E3, and it's going down sa ating I1, I2, and I3. Of course, their phase. And then let's go to the 40%. As for the 40%, we're gonna check the phase. Oops, where our phasor diagram. 40% here. Our current is still going down and it is stable in 128. Of course, our phases, some are the same. Next is 50%. Okay, 50%. Let's check out. Boom. As you can see, it's as we increase our knob, the current also decreases. Okay, my bad. I exited phasor here. Okay, let's go to the 60%. 60. Okay, as for 60, bum, and 60%. Let's go to the phasor. Okay, it is a going down. As you can see, it's 23%. Let's minimize this first. Okay, and then for the 70, we go up. 70. Okay, and then bam. Ooh, 70%, and the current is increased just 1%, 0.01. Okay, let's minimize this and let's go up to 80%. 80%. Okay, let's check. It's the current is going up now. We have our E1, E2, E3, I1, and I2. Of course, I3. Let's go to the 90%. Let's go to the 90%. 90%. Okay, let's do the 90%. The 90%, of course, as we can see our data below. And of course, for the 100%. Takes this and let's go with the phasors. Lastly, for 100%. Okay, so this it. So I'll refresh the final data here. Okay, then let's go to the next procedure. So okay, for the activity 10, does the speed n change for every increment? So as you can see, no guys, and I will explain this. And for the 11, explain how does the synchronous motor starts. And what happened to the power? What happened to the power factor of the synchronous motor when the field excitation increases? Okay. And as for 13, can the synchronous motor can be used as the power for the power factor? Number 14, how will you change the rotation of the synchronous motor? So I'll flash here. And what the application of a synchronous motor? So again, so thank you so much for listening, guys, and good night.